Okay, welcome everyone. Thank you so much for joining us in this awesome discussion that we're going to have today. On behalf of Data Science for Everyone, welcome to what we're calling Tools of the Trade Non-Coding Approaches. While we give everyone just a couple more minutes to join the Zoom, we do invite you to introduce yourself in the chat. Feel free to share your name, your organization, and even maybe why you are interested in joining the webinar today. I'll go ahead and start. My name is Hannah Kurzweil. I'm the community manager for Data Science for Everyone, and I will be your moderator this evening. I see a few questions. We are recording this session, so I just want to let everyone know that. Feel free to have your video on or off to your comfort level, but we will be sharing out all the materials from today's webinar to the emails that you registered with. So that'll include the recording, a little post-webinar survey so we can get some feedback from you, as well as the contact information of our two awesome speakers that we have today. A little bit about DS4E. We are a national initiative. We're working really hard to bring data science and data literacy into every K-12 classroom. Originally, we were catalyzed by a Freakonomics podcast, but the push for data literacy has become a national movement with over 3,000 educational leaders and over 30 states participating across the country. And we work specifically on the four things that you can see on this slide: raising awareness, gathering and catalyzing classroom resources, working on community building and policy as it relates to data science education. And so we're really excited that today's webinar is going to really hit hard at least two of these pillars with some phenomenal non-coding resources that you can immediately bring back into your classrooms, as well as building some community with some like-minded educators that you can see are also interested in this topic. I'd like to really briefly talk about our community standards. At DS4E, we welcome coalition members of all backgrounds and levels of experience to data science education. So just in that vein, in order to create room for healthy and engaging conversation, you can click the link on this slide for some of the things that we expect from what we will see in the chat and from our presenters. So without further ado, let's get into it. We're going to talk about how educators can explore bringing powerful data analysis into their classrooms without requiring the teacher or the student to learn any programming before they have to do that. So in a world increasingly driven by data, helping students develop data literacy is becoming really fundamental, almost so I would say, obviously I'm biased, as reading and writing. So while this is obviously a really important topic, many educators feel intimidated by the technical barriers that are often associated with data science. So luckily, we've brought two expert speakers in tonight that's going to demonstrate a few free, accessible tools that can help you get going with data science right away. So our speakers today bring a wealth of knowledge into the space, and I really can't wait for you to see what they have to share. We're fortunate to have Kate Miller, a data science education researcher and practitioner at the Concord Consortium, who will demonstrate how CodeApp can transform your classroom data activities. And we'll also hear from senior data scientist Alini Bessia from Nine, sorry about that, who will show us an engaging workflow that creates word clouds from song lyrics and even interacts a little bit with AI. After their presentations, we're going to open up the floor for questions. Please feel free to put questions in the chat as they're going through their discussion. And let's begin our exploration of making data science more accessible and engaging for your students. Without further ado, I'm going to hand it over to Kate Miller, who, like I mentioned, is a research associate at the Concord Consortium. She's worked on a number of data science education projects across disciplinary boundaries, as well as different age groups. She has experience working across the field of data science education as a teacher educator, a curriculum developer, and an educational researcher in both formal and informal settings. Thanks for getting us started, Kate.
Thank you, Hannah. So if we can pull up, yes, great. So I am from the Concord Consortium, and we are a small nonprofit organization based out of Western Massachusetts that focuses primarily on data and digital literacy and science education through technology. So we have a number of different online tools. And if you go to the Concord Consortium website, you can find a whole bunch of different things that we do and that we work on. But I'm going to focus on one particular tool that our company has created and maintains today, which is the Common Online Data Analysis Platform, better known as CODAP. And some of you may have heard of it, but if not, CODAP is a free open source browser-based software for data analysis. It was built specifically for use in schools with the idea that it is a tool that helps to teach learning about data science and data literacy and data science education. So it is, as I said, browser-based, which means that it can be used on any computer anywhere. There's no login required. It's completely free. All you need is a computer with access to the internet in order to use it. And as it was being built, there was sort of a lot of attention paid to the idea of interactive environments and sort of how those interactive environments can encourage exploration and play around data sets. So that's sort of a very simple overview of it. And I'm going to spend some time now demoing some sort of different things in CODAP. But if you want to play along with me as I'm demoing, then we can also do that. So I'm going to show you how to get, or at least the easiest way to get to CODAP is literally just to Google it. And it'll take you to the CODAP landing page, which has a lot of different resources on it, and I'll introduce some of those later. There's resources about the different data sets and tools, resources for educators and for developers, and sort of help and different things on this page. But right now, what I'm going to do is I'm just going to launch CODAP itself. And you can create a blank document, but I'm going to start by opening up one of our built-in data sets. There are a number of them in here, but I'm going to start with the Getting Started with CODAP to show you some basic things within CODAP. So the first thing is that CODAP takes in any CSV file. So any CSV file that you have that exists anywhere, you can literally just drag and drop it into a CODAP file and it will open up as a data table within the CODAP interface. Once you have this data set, you can move it around, you can change the sizes. There's lots of things that you can do in this that you could also do in Excel, such as sorting. You can sort your different columns. But the real thing about CODAP is that you can use it to create data visualizations to really explore the data. So I've opened up a graph. Right now, the points are just random because I have not actually given my graph any attributes to look at. But I can open up here and I can drop an attribute onto the graph here. So let's say we want to look at speed.
Sorry, you might want to share your screen. We're not following you.
You're not, oh.
I
Okay.
can see your screen.
I can see.
I can see. We can see it now.
We can see it.
Thank you.
I
Yeah.
can see, yes.
Thank you. Now we can see it.
Okay.
But can you take a step back and explain how to get there again? Because
Yeah.
I'm in CODAP and I'm not sure how you got there.
Of course. So I just Googled CODAP. And then I clicked on the very first link, which took me to the home page for CODAP. And then I clicked on Launch CODAP. And then I said, Open Document, Getting Started with CODAP. And I have documentation that I'll share at the end of this that will help you with all of this. But I'm just going to sort of step through some of the different examples of things that you can do in here. So again, any CSV file can be pulled into CODAP. This one is, as you can see, a list of different mammals with a number of attributes about them. I didn't show this earlier, but there's a you can sort of toggle back and forth between different views of the data set. So this is the standard view where you have each row is a different animal and each column is a different attribute about that animal. But there's also what we call the case card view, which is basically a summary of your data. So this is a really good way to look at what data types are within your data set. Because you can see here, this one says 27 values. So that's a categorical variable. Whereas lifespan says 3 through 80. So that's a numerical variable, numerical attribute with a range from 3 to 80. So that case card view can give you a good sense of what is in the data set that you're looking at. Okay, so I'll go back to opening up a graph again. Up here at the top are where you can access, and I'm going to go through a few of these as I'm demoing, but the graph is probably the most used one. You can open up a graph, and this has now dropped all of our cases, right? So each of these, and this is where CodeApp gets really interesting because each of these is linked to obviously an item in the table. So if I click on this dot, it finds it automatically in the table for me. And so right now, this graph isn't showing me anything because there's nothing on either axis. There are multiple ways to put things onto a graph. One is to click on the axis and you get a list of the different variables that you can put there. The other is you can grab it from your table and drag it and drop it onto your axis. So this is now showing a distribution of the speed attribute in this data set. And if I am now looking at this and I want to say, okay, what is this one? Like, what is my fastest animal? Again, if I click on that, it finds it in the data table for me and highlights it. For those of us who are math teachers or who are interested about getting into some of the math components of working with data, there are a number of different ways to measure and show measurement of the data. So you can see here, I can place a mean measurement on my graph. I can also add the measure label, so it tells me what the mean is. There are also, oops, on the ruler, there are also measures of spread, so you can do standard deviation. You can also do a box plot. You can do a normal curve, you can do outliers. So there are a number of different mathematical measurements and tools that you can use on here. If you want to look at multiple variables, you can do the same thing and drag a second variable onto your graph. And you can add now a least squares line or a plotted function or other types of best fit lines. And again, it's labeling it for you so you can see it. Height and speed probably don't have too much of a relationship or correlation, but if we're looking at, say, maybe height and mass, now we're seeing, oh, this is more of a correlation, but we also have some outliers here, and maybe we don't want to look at those. So another thing that CodeApp does, if I say, I want to remove these two from the data set so that I can zoom in on the ones closer in here. So first of all, I can drag on here to highlight a number of different points at the same time. And then if I go to the eye here, I can click hide selected cases. And what that does is it doesn't remove the cases from the table, but it does hide them from the data visualization. And then this button up at the top here resizes it. So now I can sort of see even better, that line of best fit between these two components. This data set also has, as I was showing, some categorical variables in it. So we can also look at categorical variables. So let's say I wanted to look at habitat. This is showing the different habitats that these animals are in. And again, I can select and hide. So if I just wanted to look at the land ones, I can do the same thing here where I say hide unselected cases. And now I'm just looking at the land. And you'll notice that it matches. So when I've highlighted the land here, I can see which ones are land animals on any other visualization that I have open. So all of the visualizations that you create for the same data table are linked, which allows for a lot of really neat exploration. And then if you want to bring back the cases that you've hidden, you just say show all cases again, and they come back. So one other thing, there's a lot of other, I'm going through this relatively quickly, obviously, and there are lots of different things that you can do with this. But one other thing that I wanted to show is that CodeApp has a number of built-in what we call data portals. So if you go to the plugins here and you go to getting data, these are all data plugins which allow you to pull data into CodeApp around a particular topic. So I'm going to open up the microdata portal to show you. This is from the US Census. So it comes directly from the census. It pulls data directly from the sort of US Census database. And it gives you a lot of control over where you want to look at data for. So if you're a teacher in a classroom in a particular state and you just want to look at census data from that state, you can choose your state. You can keep it as all states. You can choose which years you want to look at. So maybe you just want to look at the last 2 census years. And then there are a bunch of different attributes that you can bring in. Right now it has age and sex, but you also have marital status, family size, education, degree records. There's a bunch of different ones in here about race and ethnicity, work, income. So sort of the typical things that you would expect to be in the US Census. And what this allows you to do is there's a button down here that says Get People. And this now produces a sample, basically, from the census. And you'll see that there are now 100 people in this data set sample. And I can click this button here that says Keep Existing Data, and I can click Get People a couple more times, and now I have 300 people in my data set. There's a Map button up here that allows you to open up a map. And so you can see now with the 300 random samplings, I have at least one person in my data set from every state except for Wyoming and North Dakota. It'd be interesting to see how many times I need to click this to actually get people from at least one person. Nope, still not with 600 people. So, Wyoming and North Dakota obviously have fairly small populations, and we have not yet gotten a person from those states. So this is the other thing in CodeApp too, is that you can do these nested hierarchical data sets. So you'll notice here that this data set has 2 levels. So if I click on Illinois here, it has sorted, and this is going to show me all of the people that are in Illinois. And these are really easy to create. You can move them around. So if I wanted to, instead of having things listed by state, have them listed by education, degree record, I can pull that over here, and I can now nest my data table by education degree. So it's a really easy way to sort of sort your data in different ways and look at it. And so you can also put data information onto the map. And I'm going to actually create, so let's say we wanted to look at age. Right now, each one of these rows is a single person with a single age. So if I'm looking at, say, California, there isn't an age that I can drop directly on California, because right now I have 62 people in my sample that are from California. But another thing, again, CodeApp works somewhat like Excel, so I can actually add a new attribute, and I can call it average age, and I can create a formula that finds the mean of the age sorted by state, and add this in here. And this column now has the average age for every state. And I can now take that and drop it onto my map. And my map is now showing average age for every state. and it lets you play with the colors. You can change the colors. And you can also select. So these are the states that have the highest average age. These are the ones that are the lowest. And just like before, it selects them in the table. So I don't know where I am on timing, Hannah. Do I have time left here, or I think was about 15 minutes. So
Yes.
yeah. Okay, great. So this was just a quick demo of CodeApp. I'm happy to answer questions now or later. I'm not sure what the schedule is here, but I saw
think
there was a question about saving, and so I will address that really quickly. Yes, students can save their work. So you can go in here and you can say save, and it connects directly to a Google Drive. So this works really well if your students have access to Gmail or to Google Drives. You can connect it that way, or you can save it as a local file. So those are your two options.
Okay, great. Thank you so much, Kate. CodeUp is such a powerful tool, and it is so nice because as you can see from her, like just dragging and dropping, it's such a little effort for students to be able to just get in there and start working with data, even if they're not feeling super comfortable because there's no mistakes in CodeApp. So now I'm going to hand it over to Aline, who is a senior data scientist at NIME with a mission to democratize data science for as many people as possible. She holds degrees in computer science from Federal University of Minas Gerais, as well, which is in Brazil, and went on to complete a PhD at NYU, where her research focused on data quality and information retrieval. So without further ado, I'm really going to hand it over to her, and she's going to walk us through a super engaging demonstration. Also requires no coding, but can get the students excited about working with data.
Yeah, so hi everybody. I think that Hannah already introduced me. So what I'm gonna do is that I had prepared a demo today through which we can guess different songs using tag clouds that are based on words and lyrics, and also show how NIME can integrate with different large language models. I'm sure that some of you, especially those that work with high school students, are tired of hearing what they're doing with LLMs, right? OpenAI, DeepSeek, etc. So it might come as good news that NIME integrates with these tools very seamlessly and without requiring any code. Before I jump into this demo, I decided to show a few slides to you just to talk a little bit about the company and about its main product. So NIME is a software company with about 250 employees. The headquarters are in Europe. We have offices in Zurich, Constance, which is a city in the south of Germany. We also have an office in Berlin, and here in the US, we have an office in Austin and a bunch of employees that are remote, like myself. I am talking from New York. I saw that some of you are from Jersey, from New York as well. So always happy to connect, grab a cup of coffee, and talk a little bit about low code for education. We have a large partner network to take care of our customers in the rest of the world, but this is where the main offices are. And what kind of software does NIME produce? Well, NIME produces software for the entire data science life cycle. So when you have data, this data can be tabular like Excel, CSV, it can be images, it can be audio files, it can be text, it can be PDF. That's usually how you start a data science application, right? You have your data. Sometimes you have to blend different data sets. Sometimes you have to transform them, like Kate was talking about. Sometimes you have to transform the variables a little bit. And after that is done, often you want to visualize that. That's usually the analytics route. But often you also want to create AI or machine learning models based on that data. So we have software for that. And then when you're done with that, you're happy with your models, happy with your visualizations, you already gathered a lot of insights from your data sets, you may want to optimize that solution and deploy that as a standalone website or as a web service with REST APIs. These are usually things that people who are big customers, people who are more in that realm want to do. And we have software for that as well. So this is why here you can see that we have this cycle that goes from creation all the way to production, and it goes as a back and forth, as an infinity loop here, because we usually have to go back to creation to tweak things a little bit, make sure that they're better, and then redeploy. And that's the data science life cycle. When it comes to the classroom, what we want to do is usually covered by the creation part. We usually want to teach the students how to reason with data, how to treat the data, clean the data, how to create machine learning models, what is training, what is testing, whether or not you need to normalize the data. So usually in the classroom, the students only need KNIME Analytics platform, which is the platform that I will be demoing today, which is not only free, but completely open source as well. All of the code is on GitHub. So KNIME Analytics platform follows the visual programming paradigm. You can drag these little squares that you see here. I'm going to talk a bit more about them. I'll give a tour of the platform. And by dragging these little squares that cover atomic tasks and connecting them, you can create really complex, if you want to, right? They can also be really simple. It depends on the application. Pipelines, workflows. And no coding is required. These are some of the visualizations that you can create with KNIME. I'll show them. So the two main concepts in KNIME, and this is what I want to talk about before I even jump into the demo, are nodes and workflows. So nodes perform tasks on data. These tasks are usually atomic. For example, this node that we have here at the top of this slide in yellow is a table splitter node. So it gets a table as input. The inputs always come from the left. You configure that node explaining, for example, how you want to split it. I want to split it on row 10, or I want to split it such that 70% of the rows are on top and only 30% are in a different table at the bottom. So you configure that node, and once you execute it, you get the outputs, which are going to be these two pieces of the original table to the right of the node. And how do you know if this node has been configured properly? How do you know if this node has already been executed such that you have the tables here to the right? You look at this traffic light metaphor here at the bottom of every node. So if it's red, it means that the node has not been configured yet. You cannot really execute it. You still need to specify how the task needs to be executed. If it's yellow, it means it's been configured. So the node knows how to execute the task, but it hasn't executed that yet. So you don't have the outputs yet. And once you execute it, it turns into yellow if everything goes well. And if not, you get a little red cross at the top. And if you hover your mouse over it, you can see what the error was. For example, if you have as input a table with 10 rows, and in the configuration, you tell the node to split it such that you should have 11 rows at the top, you're going to have an error, right? Because there are no 11 rows, there are only 10 rows. And the other main concept is the workflow. This is what you really create with KNIME. And you do that by combining these different nodes. So in this tiny example here, we start with a node that reads a CSV file. So that's the name of the node, CSV reader. And you can add an annotation at the bottom to make it even more legible. And here we can see that this node is going to read a sales file with sales data from 2008 to 2011. And this file has already been read, right? We see here the green light. And now this file here is here available to the right of the node, ready to become the input of another node. And this is what we do. We send this file to a node named column filter that in this particular case is configured to select three columns here: country, date, and amount.
So sorry, it looks like you're not sharing your screen. I might be wrong, but it looks like we're not following you. Thank you.
We can see your screen.
I can see the screen here.
Yeah, Larissa.
I can see the screen.
I can see the
It's-
screen.
Oh, okay, great.
All right, so after the columns have been selected, this node has also been executed. We see because it's green, we are going to have as an output a smaller table, right? So instead of having the big sales table we read in the beginning, we now only have a table with three columns. And we keep doing this. Now we want to exclude some rows from this table for which the value for country is not known. So we can filter those rows. We configure the no row filter for that. And once we execute it, we're going to have a table with fewer rows and also fewer columns. And then we keep going.
I apologize, but I have to say, I don't see any screen. Like I see an example screen, but I don't see any shared screen either. I mean, I'm assuming yours is dynamic and you can see things happening. I don't see that.
Yeah. So what we see the nice slide, and now
There,
you're
there.
sharing a screen. Yeah, now we see the nodes and the workflows. Thank you.
I didn't modify anything. Okay, as long as you're
If
seeing
I
that,
found
that's
that
what matters.
if you look at the very top, it shows you whose screen you're viewing, and if you click on view options, you can see other people's, you can see there's multiple screen shares. I
Thank you.
found that problem as well.
Thank you.
Oh, thank you.
Okay, so basically, in this little example here, after we have this table that is already clean, we have two branches here. One to the bottom that simply gets this data and creates a pie chart in which you're going to visualize the sales by country. And at the top, we have a separate branch that is going to run independently that will remove duplicate rows because that's a part of the pre-processing that we want to do. And after that, we will visualize the sales by time using a stacked area chart. So I will show in the platform more examples, but I just wanted to explain these two concepts to you. So how powerful is this platform? How much can I create with that? The platform has over 4,000 nodes, but please do not feel overwhelmed by it. It's just to show you how powerful it is. When you download and install the platform, which is very easy, I'll show in the next slide, it comes with a good set of nodes for you and your students to get started. Lots of nodes to pre-process data, read data, create machine learning models, and many visualizations. But if you want, for example, to play with image processing, text processing, deep learning, integrate with large language models, you can also do that with KNIME. To install the platform, go to knime.com/downloads, and you can select the KNIME version for your computer. One of the cool things about this platform is that it runs in all the main operational systems, so Mac, Windows, and Linux. You just have to download it, extract the file, and then install it. Okay, so now let me quickly jump and share my screen again because I want to share the platform with you. All right. Can everybody see the platform?
Yes.
Okay, so here I prepared a little demo. I will give an overview of how the platform works. This is how it looks like. It looks almost like a browser, right? So this is the workflow that we have open here. Guess the song, let's play. But I could open all the workflows as well. For example, I taught last week and I was explaining how to process reviews from hotels. So in yellow here, you can see that I have this all the workflow open. So all of them stay here at the top. But let's go back to ours, okay? Guess this song. So you can read a little bit about the workflow that is open by clicking this tab here, Info. I edited this to explain that this is a workflow that I developed for this demo here. I could add more information about what it needs. I added a few tags as well. Demo, let me add this new tag here and I save it. And this is the information you get when you see this tab to the side. If you click a node, any node, what this tab shows is information on the node. So all of the documentation for all of the nodes is here. This really comes in handy because the students don't have to be jumping on the browser and back, so they don't get so distracted. They can already get the documentation for the nodes within the platform. So here you can see that this table reader node reads files that have been written using the table writer node format. If I go in nodes, this is how I search for new nodes. For example, I can search for the CSV reader node. And what I do is that I grab a node, any node that I want, and drop here in this main part. This main panel that you see here is the workflow editor. So this is where the magic happens. You can see that the CSV file, the CSV reader node that I just dragged is red because it hasn't even been configured yet. I have to click here, click on this little gear, and state what file I want it to read, right? So if, for example, I wanted to read this CSV file here, cases. And then now it's configured because I told what file I want to read, but I haven't read it yet. And if I hit play, it will read. And once it is available, I can also see all of the data in this panel here at the bottom, which is the inspection panel. So in our case, what I read was a file that has a lot of information on songs. I got popular songs. We have their names, we have the singer, and we have the lyrics. So what I did is that after I read this data, I decided to pick one of these rows at random using the row sampling node. This is how I configured it. I just asking to get one row at random, draw randomly. And the one that I got was a song by Harry Styles named As It Was, right? But maybe I can, if I click here, I reset this node. And if I execute this again, now it's Anti-Hero by Taylor Swift. So what I do is that I have this meta node here. So every time you see something in gray in the platform, it's a meta node. It's nothing complicated. It's just an encapsulation of a bunch of nodes that do a specific thing. So here, because I want you to guess the songs based on the words that appear in it more frequently, what I do is that I have to calculate the frequency of the different terms in the lyrics. So to do that, I will need a few nodes, and that's why I encapsulated that. So the workflow doesn't look too crazy, right? With too many nodes. So here in the term frequency, I turn the lyrics into document. That's a type from NIME. And you always can see here what I have. So the lyrics go as I have this thing here. I think this thing where I get older, but just never wiser. Midnights become my afternoons, da da da. So if I want to count the frequency of all of the words ignoring the case, I can bring them to lowercase. And then here, let me see if it's configured for lyrics. And then the document is going to be in lowercase. This is the document with the lyrics. We can inspect that. And then I want to erase the punctuation, remove some stop words, ignore the lyrics for now. I'm just doing that in the document, which we can inspect with the document viewer node. So for example, by now I have removed the punctuation. And let me see the lyrics. You see, wiser, midnights, afternoons, I have removed a bunch of words that are stop words. Stop words are words like the, a, and words in English that are so common that they don't really mean anything. And we don't want these terms that are super common to inflate our word cloud with which we are going to guess the song. So we remove them. Then we calculate the frequency of all of the terms, turn them into strings. This is a technicality. I chose this demo more to show the cool things that I can do. And then we can use the tag cloud, which is a visualization node, to display the most common terms in this song. And then we can ask the students, for example, if they can guess what the song is by seeing the most common terms, right? Time, anti-hero, exhausting. So maybe the students can see that and know that it is a Taylor Swift song, right? I would not guess because I don't know much about Taylor Swift, frankly, but the students could guess. And then you can also create a little game with the students in which you get the top words in the lyrics. So here it's another meta node, right? With a little pipeline of nodes. And when we get the top words, it says here that they are sun, stare, anti-hero, to, directly, agrees, tea, high, time, and mirror. And we can create a little prompt for a large language model. In this case, we basically want to ask ChatGPT, what's the name of the song that has these words in a high frequency? And then we send the list of the words. And then we prompt ChatGPT. I think that, yeah, my credentials are here. Yeah, I think I'm going to have to use my credentials again. So basically, how much time do we have? Do we have enough time to show this part of the demo?
Yeah, you have about 3 more minutes.
All right, so let me quickly stop sharing my screen just to get my credentials here very secretly so you cannot see. Okay. I think it's because I reset the platform. All right, so now let me share again. And now that we are connected, we can send that prompt, like what's the name of the song that has these words in a high frequency? Sun, stare, da da da. And then we ask ChatGPT. One of the things that people underestimate is that ChatGPT sometimes is a little slow. So what ChatGPT is saying is that it couldn't find a song that includes all of these words with high frequency. And then we can keep playing, right? So if we pick another song, this one is One Kiss by Calvin Harris and Dua Lipa. The tag cloud that we can show to the students, we don't tell them what the song was, right? That we picked. And these are the words: possibilities, look, kiss, love, falling. And we can see if they guess. And then we can send the same song to ChatGPT. Once again, get the most popular words. And it's saying that it is Heaven by Bryan Adams. Um, that's wrong, right? This is One Kiss by Calvin Harris. So we can play with the students, and this is one of the applications that we have created in a course for high schoolers that we had last summer. One cool thing that I want to say, the last thing I want to say is that if you want to learn more about KNIME on the fly, there are resources that I want to share with you. But if you want to learn KNIME on the fly, we have this tab here in the platform named Kai that allows you to play with our AI assistant. So let me log in onto that. So now that I am logged in, you can ask questions to Kai, right? So for example, Kai, how can I visualize the most frequent words in a text? So you can ask a question. This is one of the modes. And Kai is going to recommend you nodes and explain all of the different nodes you can use and what is it that you can do with KNIME, right? So the entire pipeline. And there is also the build mode that if you ask something like, Kai, please create a visualization for the most common words in data set. Let's say the name of this data set. Combined song info dot table. So what it does is that it's analyzing the requirements and it can create. So it created, we encountered an issue. There is a workflow open here. Yeah, so basically I would have to remove all of these nodes here. But it's one of the modes that you can use to both ask questions about nodes. This really comes in handy when you're learning about KNIME and you want to ask, okay, I want to sort the data. I want to filter the data based on some columns or on some values. So you can ask questions and the assistant helps you. The build mode is also really helpful, but I personally use the Q&A more. And yes, I think that this is what I wanted to show, just try to motivate you to use KNIME. We have a bunch of resources that can come in handy for learning with KNIME. Let me just give one last gift to you, which is all of these different resources. Why we have a learning center through which we have a bunch of courses that are free. They go from very basic, so just installing the platform, learning how to filter, learning how to do very basic data processing, all the way to very advanced courses for text processing, and all of them are free. We also have cheat sheets, booklets, and a channel on YouTube, 9TV. All of these resources are free. And if you or your students want to get certified and show that you are certified, we have a bunch of different certifications. The L1 is free, always for everybody, but the other ones cost $100, $150. But with this coupon code here, GS4 everyone dash 0425, you can get any of the certifications for free until the end of the year. And then, you can brag about it on LinkedIn or just know that you have the knowledge to teach with 9. And this is all I had to say.
Can you repeat the code?
I'll put it here on the chat as well, but I believe that Hannah is going to share this.
Yes, yeah. So just so everyone's aware, all of the resources that you got today, we will be sending out, including like the tutorials for both CodeApp and for Nime. So thank you, Kate and Aline, for walking us through those. Those are both great examples. I have a couple questions. I know we're kind of running out of time. A few that are just like some quick answers. And the first one that I think is really important is, what age group do you find works best with this platform? Like obviously we want to kind of see like how young are people really interacting with data on these platforms well.
I personally have seen teenagers 13 and above being completely savvy on this.
Great.
Especially now that we have the AI assistant, they ask questions and they develop workflows that are pretty complex. This workflow for Guess the Song, they work together with us creating this.
CodeApp was designed with sort of 5th through 12th graders in mind. However, I know that it has been used in plenty of college programs, and I know some people that have used it with students as young as 2nd grade. So, it was really designed with that sort of 5th grade through 12th grade in mind, but many people are pushing the boundaries on that on both ends.
Awesome. And then another kind of logistical question is, like, we understand obviously that educators have so much on their plates already. I'm not saying for mastery of these platforms, but in order to feel like confident in just implementing maybe even one lesson in their classrooms, how long do you think they would need to spend on your platform just kind of like tinkering around before they might be able to do that?
I would say that 4 hours I've seen, because 4 hours is our basic course, right? That's how long it is. And that's a course that we usually teach to adults. Again, we were very successful using the same materials with teenagers as well. Yeah, and they play around, they learn about the concepts, right? So it's 4 hours of data science, really, data analytics, basic data analytics with the tool. So it's kind of combined. And yeah, by the end of that, they're able to do a lot. 45 minutes here, Mahmoud says. So yeah, it really depends on how much you want to introduce. The thing with NIME is that there are so many resources that sometimes, I send a few emails to the students, they get it going already.
Yeah, I mean, CodeApp is so intuitive and sort of designed to learn as you go and explore. The UI is pretty friendly. So, I have done short training sessions with teachers, and then they take it into their classroom and is sort of a learning as they go. And I've certainly seen classrooms of middle school students be able to pick CodeApp up pretty quickly and actually get to doing data analysis within a 45-minute period. So, on the flip side, if you're doing complicated things with CodeApp and bringing in plugins and writing in formulas and, there's a lot to do with it that can be learned, but sort of just right off the bat, it's pretty easy to just drop in a data set and, show a graph. So, I think the learning curve just sort of continues to go as you get deeper and deeper into its capabilities.
Yeah. Okay, just to be aware of everyone's time, I do want to say if you have any questions for any of our speakers, please feel free to reach out to them. They have their contact information in the resources we'll send out. But one last thing, because it is a little bit close to my heart, is do you think, I guess, could you share one example that you've heard from a teacher actually working in a classroom that was not a math or computer science teacher who used your platform super successfully in a non-STEM class?
Yeah, absolutely. I've actually been working recently with some 8th grade social studies teachers using CodeApp to bring historical data sets into their classroom as primary resources. So looking at, for example, the data set of Japanese who were brought to the Manzanar internment camp and actually looking at the intake data at the Manzanar internment camp. And I am just sort of constantly, those teachers are talking to me about how they are impressed with like the different students who tend to shine in their class when they're doing work with CODAP. A teacher said to me, I have the student who's super quiet, who sort of never is engaged in social studies. And on the days that we do CODAP, all of a sudden they are a classroom leader. So, I think there's a lot of really great things that can be done with CODAP, and I've seen teachers and researchers and others using it in English classrooms and social studies classrooms, so not just in STEM fields.
Yeah, NIME is most of the professors that I'm in touch with, 99.9% of them are in colleges, right? So we have a bunch of professors working with psychology students, business analytics students, pharmacy, although pharmacy is not STEM, I don't think, but it's life sciences, but pharmacy, journalism. So using NIME very successfully to do very advanced things, right? When it comes to high schools, high school teachers, I'm not in touch with many of them. I know of one who has used NIME for teaching, but it was in the realm of STEM for high schoolers, right? It was teaching data science for high schoolers.
Great. Thank you so much. I really appreciate your guys' time coming out and talking to us about this. And obviously, when it comes to data, getting it relevant to our students' lives and having these ways to like really put their hands on it and see visuals is so impactful. So thank you so much. Before we close, I just want to run through a couple things. If you are interested in more data science topics, please make sure that you're following us on the Data Science for Everyone community channels. We have a Slack channel, we have a newsletter, we're on LinkedIn. You can reach us on Twitter and on Instagram. We have a bunch of stuff in our resource center, including the things that you saw today, as well as a lot of other tools that you might be interested in. So go ahead and look on there if you're looking for something that you might want to put into your classroom in the next week or before May when classes are over. And then I want to also plug that if you have any questions about these platforms or really any way that you want to implement data science in your classroom, I hold monthly office hours, and the next one is the same time next Wednesday. So please feel free to register for that, and you can come in if you've spent the week looking at NIME or at CODAP and you want some more information. Come on in, and I can help walk through some of your questions with you. And then, last but not least, if you are a little bit inspired by this webinar and you do want to dip your toes into some really kind of beginner and friendly coding type ways to implement data science in your classrooms, please come next month. We're doing a sequel to today's lesson, just about some more coding approaches. And we're having two rockstar teachers that have really done some great things with their students come talk to us about some of the things that they've done and what they've seen in terms of student engagement in their classrooms. So there's a registration link in the chat, and we also have a QR code that you are more than welcome to sign up. We'll be sending all the resources you saw today out in an email, as well as a little post-webinar survey that we would really love for you to fill out if you have a couple minutes. And yeah, I think that is it from us. Again, thank you so much to our speakers. And for those of you that joined, please, we cannot thank you enough. I know that your time is valuable, but it means a lot that we know that you're out there doing the work, boots on ground, and getting this data and these skills into the students' hands. So thank you and have a great evening.